Hello everyone, we've got a nice numerical methods question here from chapter 10. So let's have a look, exam question. It says the curve with the equation y equals f of x, where f of x is equal to x squared add ln of 2x squared minus 4x add 5, has a single turning point at x is equal to alpha. Show that alpha is a solution to the equation 2x cubed minus 4x squared plus 7x minus 2 equals 0. Now, when we have these kind of questions where we've got to show that the equation of a turning point is a particular thing, we need to differentiate the function, set it equal to 0, and then rearrange. So here's our original function, f of x, and we are going to be differentiating it. Okay, so when we differentiate x squared, it goes to 2x, and when we differentiate our ln of 2x squared minus 4x add 5, we have an outer function is the ln, an inner function is this. So using the chain rule, when we differentiate ln of something, it goes to 1 over that something, and then we multiply by the derivative of the inner function, which in this case is the derivative of 2x squared minus 4x add 5. So that's going to be 4x minus 4. So this has come from the chain rule. Now, in the next step, we set that equal to 0 because it's a turning point. And now we've just got to rearrange this into what's shown in the question. I've multiplied everything by this denominator here. So I've multiplied that one and that one and that one by the denominator. And that gives me this 2 times 2x squared minus 4x add 5 plus 4x minus 4 because it was divided and now it's now been timesed. We just expand the brackets and collect like terms. Okay, and when we expand the brackets and collect like terms, we end up with 2x cubed minus 4x squared add 7x minus 2 equals 0 as required. So that's quite a nice, very nice, accessible 4 marks for part A. Now, part B, it says the iterative formula xn add 1 is equal to 1 over 7, open brackets, 2, add 4xn squared minus 2 times xn cubed. Is used to find an approximate value of alpha. Starting with x1 equals 3, calculate, giving your answer to each of 4 decimal places, x2 and x3. So this is what I refer to as the spam equals method. So let's have a look at this one. Now, we're using the sort of updated calculator here. So first of all, we need to program in 0.3. Okay, oops, let's just do that. Delete, so 0.3. Okay, so that's programmed into our calculator. Now we need to press the fraction button. Okay, and we need to put in 1/7 in there. And then we open the bracket and we have got 2 add 4. And then basically what we need to do now is we need to use the answer button. Okay, so you use the answer button and that's what helps us program in the recursive iteration. So it's 2 add 4 times answer squared minus 2 times answer to the power of 3. Go across 1 and then close the bracket. So we have that now programmed into our calculator. So every time we press execute now, we're going to go 1 time round the recursive iteration loop. So I press exit once, and then on this calculator, I need to format that into a decimal. So that gives me that my x2 is 0.3294 to 4 decimal places. I press it again, and this is now my x3. So we're not asked for x3, but I'll just write it down anyway. That is 0.3375, correct to 4 decimal places, and then press it again, and we have 0.3398. So 0.3398. So that's how you program the recursive iteration into your calculator using the answer button. Okay, that's great. Well, that's B part 1 and 2 done. That was a very nice 3 marks as well. Part C, the final part of this question. So it says using a suitable interval. Now this sometimes does cause confusion with students. Students are often a little bit confused about exactly what a suitable interval means. Show that alpha is 0.341, correct to 3 decimal places. Now, when they give you this, we have that alpha is equal to 0.341. We basically look for the lower bound and the upper bound. And we're going to demonstrate that there is a change of sign Okay, so we're looking for a change of sign in between the upper bound and lower bound. Okay, so let's calculate. Now the lower bound of 0.341 is 0.3405 and the upper bound is 0.3415. So I've decided to call the function h of x, the 2x cubed minus 4x squared add 7x minus 2, and I've evaluated that function at the lower bound and the upper bound. And you can see that when we work it out at the lower bound, we get a negative answer. And when we work it out at the upper bound, we've got a positive answer. So there is a change of sign. Okay, so that means that there is at least one root in that interval. So they're looking for you to write down certain things. So we have a change of sign. So you need to make a note of the fact that there is a change of sign. You would need to mention, very important, you need to mention that the fact that the curve is continuous, okay, that there's no asymptotes in there. And then once you've got those 2 points, you can say, therefore, alpha is 0.341, correct to 3 decimal places. I hope that is how we do that question. I hope that you found that useful, and I will see you in the next video.